the differential form of the fundamental laws. Before we go further to discuss about this topic, I would like to explain about the coordinate system. We have two common coordinate systems, and we will discuss both systems of coordinate here in our topic here. So the first coordinate is the Cartesian coordinate. So this is the very common coordinate. You already know about the Cartesian coordinates. And the other coordinates that we need to know is the polar coordinates. So this is the Cartesian coordinate. A Cartesian coordinate system is a coordinate system that specifies each point uniquely in a plane by a pair of numerical coordinates, which are the signed distance of the point from two fixed perpendicular directed lines measured in the same unit of length. Each reference line is called a coordinate axis or just axis of the system, and the point where they meet is its origin, an ordered pair 0, 0. The coordinate can also be defined as the position of the perpendicular projection of the points onto the two axes, and sometimes three axes, expressed as signed distance from the origin. So this is the example of Cartesian coordinates. I think you already know about this kind of coordinates. So we have the horizontal axis here, and usually it will label as x-axis, and the vertical axis here, and normally it is labeled as y-axis. And in some question, they will use a three-axis, so mean this is the x-axis, this is the y-axis, and the z-axis is the axis which is normal to the screen of your computer or normal to the paper here. So to write the location of points, so we will write according to the location of x, y, and z. For example, if we only have two axes here, if we want to point a location at this point, so we will write as 2, 3. So it means it's located at 2 units at x-axis and 3 units at y-axis here. So it can be negative side like this, and it will we could have positive value of coordinate like this. So let's say we have a motion of a molecule here. For example, we have one element, the coordinate is x1, y1, and then it moved to the new location, which the coordinate is x2, y2. So we could say that it moved with a certain velocity, and we could write the velocity from point x1, y1 to the point x2, y2 here is the velocity of q. And this velocity is the resultant velocity, because if we discuss about the component velocity, we could say this component, this molecule have the component velocity of u, which is the velocity parallel with x-axis, and the component velocity of v here, which is the component velocity that parallel with y-axis. So to calculate the resultant velocity, we could use common trigonometry equation. So we have square root for u square plus v square as shown here. Now I would like to introduce you about polar coordinate system. In mathematics, the polar coordinate system is a two-dimensional coordinate system in which each point on a plane is determined by a distance from a reference point and an angle from a reference direction. The reference point, analogous to the origin of Cartesian coordinate system, is called the pole, and the ray from the pole is the reference direction is the polar axis. The distance from the pole is called the radial coordinate or radius, and the angle is called the angular coordinate or polar angle or azimuth. So this is the example of polar coordinate. First, let's say we have one molecule here and it's travel in circle direction like this. So means this molecule keep rotate at its trail like this. So it is better for us to mention the coordinate of this molecule by using the polar coordinate. So to use polar coordinate, we will write polar coordinate with the distance of its radius and the angle of its location. So for example, if our point is here, so we could write the location of that point is r theta. If the radius is 5 meter and the angle here is 45 degree, we could say that the location of this point is equal to 1 meter and 45 degree. Then this molecule also have the component velocity because we have a radial direction here and the angle of theta here. We could have the component velocity of radial direction and we write as UR, and the tangent of the velocity at this angle, so we call it the tangential velocity, so we write as U theta, and the resultant velocity we could write it is equal to Q here by using this equation, and it is similar with the Cartesian coordinates. So we have Q is equal to square root UR square plus U theta square.